We know that in order to work out the points of intersection of a line and a quadratic curve, we solve their equations simultaneously. There is a possibility when a straight line intersects the curve at two distinct points. So clearly in this case we can say that there are two distinct real roots. Similarly, there is a possibility when the line intersects the curve at a single point. We can say that the straight line just touches the curve at a single point. This line is then called tangent. The tangent to the curve, because this line touches the curve at a single point, therefore it is known as a tangent. And when the line touches the curve at a single point, there is only one root, which is called the repeated root. Or we can also say that we have equal roots. And the third possibility is that the line does not intersect the curve at all. Now in this case, clearly there is no real solution to the problem. So we can say that no real roots, no real value of x, no solution set. From here, if we look into the discriminant which we have discussed already earlier, b square minus 4ac, and we have already discussed that if b square minus 4ac is positive, that if it is greater than 0, then there are two distinct real roots. We also know that if b square minus 4ac is equal to 0, then we have equal roots or repeated root. And finally, if b square minus 4ac is negative, that is, if it is less than 0, there are no real roots. The other conclusion which we can make now from the discriminant is that if b square minus 4ac is greater than 0, then there are 2 points of intersection between the line and the curve. So we can say that 2 distinct points of intersection. Also, if b square minus 4ac is equal to 0, we can say that the line is tangent to the curve. Or we can say also that there is only one point of intersection between the line and the curve. And finally, if the discriminant is less than 0, there is no point of intersection. Let's have a look into an example. Find the value of k for which y is equal to x plus k is a tangent to the curve y is equal to x square plus 5x plus 2. This is our quadratic function, and this is the equation of line, and this line is tangent to the curve. It means that this line touches the curve at a single point. And using this information, we know that in that case, when the line is tangent to the curve, the discriminant b square minus 4ac is equal to 0. This is the information which we will use in order to work out the value of k. At point of intersection, the equation of line and the equation of quadratic curve have the same value of x. Therefore, we can start with x square plus 5x plus 2 is equal to x plus k. Or further simplifying it, we'll get x square plus 5x plus 2 minus x minus k is equal to 0. And if we rearrange this one, we'll get x square plus 5x minus x is 4x, and these are the constant. 2 minus k is equal to 0. This is a quadratic equation now, and clearly the value of a is 1, value of b is 4, and value of c is 2 minus k. Using the fact that b square minus 4ac is equal to 0, we can write b square minus 4ac is equal to 0. It means that 4 square minus 4 into a is 1 and c is 2 minus k is equal to 0, or 16 minus 4 into 2 minus k is equal to 0. Solving this one, we will get finally 4k is equal to minus 8, which gives us k is equal to minus 2. That's all for now. See you next.